So now we're going to talk about the second case of partial fraction decomposition, which is when the denominator has repeated linear factors, which means that they appear more than once. So our steps are going to stay the same. So we're first going to factor. I'm going to go ahead and just do this off to the side. Right, and this one's pretty easy. So we have x squared times x minus 1 to factor it. So now when we do our partial fraction decomposition, we want to think about the fact that x squared out here means this is actually a repeated factor because it's x times x. So when you have repeated factors, you actually have to build up to the exponent. So our first fraction is going to be a over x, and then we're going to add on a second fraction where it's x squared. So we built up from 1x to 2x, so x squared. We'll put a different coefficient on the top, so b. And then our last factor, x minus 1, is going to get a c. So that's our partial fraction setup. And then we're going to go ahead and create our common denominator. So I kind of like to do this without the denominators at all. So I'm just going to leave the numerator over here the same. So my first fraction would need another x and the x minus 1 factor. My second fraction has the x squared but needs x minus 1. And then the c factor also just needs x squared because it already has the x minus 1 group. So now we're going to go ahead and plug in some x values and figure out what a, b, and c are. So I'm going to start with the easiest case with letting x equal 0. So if x is 0, I get 4 times 0 squared, right, plus 2 times 0 minus 1. And that's going to equal a times 0 minus 1 plus b times 0 minus 1 plus c times 0 squared. Right, so the a term is going to cancel out. The c term is going to cancel out. And over on the left, I'm going to get negative 1, and that's going to be equal to b times negative 1. So negative 1b. So positive 1 is equal to b. So now the next easiest number to plug in is x equaling 1 because that'll cancel out the other terms. So if I let x equal 1, I'm going to get 4 times 1 squared, which is 4, plus 2 times 1, which is 2, minus 1. That's going to equal, the a term is going to cancel out. Anything that has an x minus 1 will cancel out. So I'm going to end up with c times 1 squared. So that's going to be 5 is equal to c. And then from there, I can't plug in another x value that will cancel out anything. But I do know that c is now 5 and b is going to be 1. So I'm just going to pick another number. So I'm going to let x equal negative 1. I like to choose smaller numbers just because the exponents get a little hairy otherwise. So I plug in negative 1 to the left. 4 times negative 1 squared is 4. That's going to be minus 2 minus 1. That's going to be a times negative 1 times negative 2. B is 1, and that's going to be negative 2 plus c times negative 1 squared. Okay, so that's going to be 4 minus 2 minus 1 is going to give us 1 equals 2a minus 2. Oh, and I forgot that c was 5. I should have plugged that in. My bad. That's going to be 5 times 1, so plus 5. So that's 1 equals 2a plus 3. That's negative 2 is equal to 2a. So then negative 1 is equal to a. So now we're just going to go ahead and set up our integral. So we have the integral. A was negative 1, so I get negative 1 over x. B was positive 1 over x squared. And c is, not c, c is 5. And that goes over the x minus 1 term, dx. So then we're just going to go ahead and factor. So as a reminder, right, this is really like x to the negative 2 power. So if I integrate, negative 1 over x is going to turn into negative the natural log of the absolute value of x. If I integrate x to the negative 2, I'm going to get negative 1 x to the first. Negative first, I should say, and then that's going to be plus 5 times the natural log of x minus 1 plus c. So the only way to clean up this answer, since my natural logs have different coefficients, is to just rewrite that negative exponent. So it's going to become negative 1 over x, adding on our natural log here and our plus c. And then we're all done. So go ahead and try the OYO question for case 2.